Hi, I'm Rajesh. So, part of the additive manufacturing course, today we are going to discuss about the reverse engineering. Introduction to reverse engineering. So, reverse engineering is one of the revolutionizing concepts that took over the world. Okay, so it is an engineering process. Basically, it consists of two different steps. One is digitizing the parts, and another one is building the CAD models. So you may wonder why it's called as a reverse engineering. Because in engineering, the design precedes the part manufacture. So before producing a part, a CAD model is being created and then it moves to the production stage. But in reverse engineering, what we are going to do is we are going to study the part that is already existing and we are going to create a design for that part and finally manufacture that part. Since the whole process is reversed, it is called as a reverse engineering. So from physical part, we go to a CAD model, and from CAD model, we are going to try to create a part prototype. It is the process of extracting knowledge or design information from anything man-made and reproducing it or reproducing anything based on the extracted information. The process often involves disassembling something, a mechanical device or an electronic component, and analyzing its components and working detail. So during the World War II, this reverse engineering caught the attention of the world. So when an enemy tank or an enemy gun or any other enemy's electronic component is seized, then the engineers try to disassemble the part, study it, and try to understand and develop their own design. The beginning for reverse engineering. The one, two. So, what is the motivation for reverse engineering? So, it is helpful for interfacing. So, mainly, as I told you in World War One, so it was used for military or commercial espionage. So, we are trying to copy. Third thing is that product security analysis. So after creating the product itself, we can do a reverse engineering and see how far we are able to recreate our part. And it is also very helpful for academic or learning purposes. So sometimes, finally, it is also helpful in saving the money. So you can find one of the spare parts by reverse engineering. So what is the reverse engineering process? So it involves prediction. So what is the purpose of the product, how it works, and then observation, and then disassembly. So this is an important part. We will try to disassemble and then analyze carefully all the systems and subsystems, all the design, safety, and other controls. And finally, we need to test carefully reassembling the product, operate the device, and record observations about its performance in terms of functionality. Documentation, which is also an important part that finally follows it. Schematic diagrams are produced, a list of materials are produced, and sometimes we may also record any refinements or upgrades that may be needed. After that, this process can be reproduced. So this is the process of reverse engineering. So in reverse engineering, primarily it was mechanically disassemble and measuring the parts and redrawing it. That was a traditional method. But with the advance of the very powerful 3D scanners, it is very easy to capture an object's contour with millions of points and then try to recreate a 3D model. From the 3D model, the 2D model can be done. Laser scanners can be very helpful in creating these designs, and they can be handheld portable units, or sometimes they can be based on CMM. They can be attached to a CMM Pro, and it will be trying to capture the details of the part. Here you are looking at the various different types of laser scanners. Laser scanner